I've just pressed record on our new lightboard. It's very simple to operate. You simply insert a USB drive, press record to start recording, and then write on the board to create an engaging presentation. When you're finished, press record again to stop the recording and take your USB drive, put it on your computer. It's a very small file, easy to deal with. It couldn't get any simpler than that. It is a one-button operation. So think about it. Come and try to record your own lightboard presentation. Your students who are viewing it online, whether they're face-to-face students viewing it outside of class, they'll know that you did something special just for them. But suppose that you also want to present some information from a PowerPoint presentation like you do in a class. Well, you can do that too. Just bring in your computer, just like you would to a classroom, and connect it to the HDMI cord, just like connecting to a projector. And if you want to do that, there is another row of buttons for those who want to do that sort of thing. You can add a PowerPoint presentation. It's actually sort of transparent. You can make it larger, put it on the other side, and so on. Try to keep it simple, easy to operate. It's just a couple buttons. Or turn it off. It's just that easy. Come and give it a try. Here's my go. A motion diagram is like strobe photography of the motion of an object over regular intervals of time. Can you see from this motion diagram where the ball is moving with a larger speed, with a faster speed? Well, during this time interval, the club only travels a small distance d, so dividing that by the time interval, delta t, will give me the speed at this, over this time interval. Whereas if we were to find another place, say down here, the club travels over the same time interval a larger distance. The distance from initial to final is a displacement in this direction. That displacement, or distance, divided by the time interval is the speed at that location. We can compare the speed here to see where the club is moving faster. Interesting things could be done, for instance, looking at the flexion of the ankle throughout the motion, but I'm just going to track those 2 points in the tracker software. You see the red dots. So at various times I've outputted the x and y coordinates here into a spreadsheet, and I've made a graph. Is it a function? Well, no, I remember from Algebra 2 that in a function, every position on the horizontal axis can only have one value on the vertical axis, but there are 2 values here associated with the same place, so this is not a function. We can tell the same story with the graph of the vertical position of the ankle as a function of time, and we can see that is sinusoidal motion. Circular motion is generally sinusoidal motion if we look at one coordinate as a function of time. Jenny runs 1 mile to the northeast, 1 mile, and then 1 mile south. Graphically, find her net displacement. Now, displacement does not mean how far did she run. It means what is the difference between her final location and her initial location. The displacement can be represented as a vector that goes from initial to final. That would be her displacement. And if we were to also ask what is the value of her displacement, and even what is the angle of her displacement, you could do that too. You would do a little bit of trigonometry. I would break this triangle up into right triangles because I know a lot about right triangles. If I knew the length of this side, let's just call that A, and this side, oh, let's call it B, then this side would be the square root of A squared plus B squared. That would be my solution strategy. Okay, post whatever questions you have in your reading, and we will pick up this discussion in class. I'll look forward to seeing you then.